So already we have learned the GBDT concept. So how the GBDT is important, and when we have applied the GBDT concept, what is its time complexity, what it is advantage, we have already learned these things. So they have another boosting technique. They are also have another boosting technique. That's the boosting technique is called the AdaBoost. They have another boosting technique. So this boosting is called the AdaBoost technique. AdaBoosting. AdaBoosting technique. So mainly these AdaBoosting techniques are used to classify image processing in image mainly in image. For image data, this AdaBoost technique is mainly used, and mainly in image the face detection. For a face detection, this AdaBoost is used. For a face detection, this AdaBoost technique is used mainly. And now we will see by using simple toy example that I am taken this example from an block that I am typing the simple toy example of the AdaBoosting. Just simple type it on Google, the toy example of the AdaBoosting, then you can easily find. And first 2 or 3 pages you can easily find this example. And this example, the main advantage of this, it is nicely explained. Explanations of this through this example is so easy, and it is easily understandable. Okay, so let's start. So first, what I have to do? So in initial stage, this is the sample we have taken here, the 2D data sets. The data sets of our here is actually 2D data sets, and our assumed classifier is a binary classifier. It means it is either positive or it is a simple negative. We have taken here 2D data sets, and our classifier is the binary classifier. Binary classifier. Okay, so the first initially we have to build the model D1. This is the initial stages. This is the initial stages that we have to build. So in initial stages, so our classifier is so weak that it may be vertical or horizontals, that divides our whole plane in two parts. This divider will be in vertical or in horizontals. So if we just take the decision tree, so this is the sample, the decision tree, and with depth is equals to 1, with depth 1. This is the simple decision tree with depth 1. Or in general language, these things is called the decision stamp. These things in general called the decision stamp. If the decision tree is depth 1, this thing is called the decision stamp. So this is the sample our first initial stage. Now in the next stage, what we have to do? In the next stage, we have to, using these data sets, we have to build a classifier. So the classifier is, let's take the classifier is our, we have that build h1x, that we have built here, h1x, our build classifier here, h1x. Okay, this one. And the classifier that is equals to vertical classifier, and this divided, the left side of this classifier is positive point, and the right side our classifier is the negative points. But we have seen that in this classifier, using the data sets D1, we have built the model, H1. Okay, so in H1 we have seen that here I have 3 misclassified point. Here we have 3 misclassified point, this one, and this one. Okay, now we have to build the data sets using the help of these models. How we will build it? We have built the data sets D2 by giving the importance of the misclassified point. So what is the misclassified point here? Just see these 3 circle positive points. These 3 circles positive points are the misclassified point. This is the simple misclassified point. Misclassified point. Now we have given that to build the data set D2 here. At first round we have to build the data set D2. We have given the more importance to these data sets. Means there, just see this, we are given the more importance. Because of this we have using the bigger sign of this misclassified point. Actually we have given the more importance of this data set. Okay. Given more importance of this data set. This is the first step we have to do. Okay, in the next steps, using this data set D2, we have to build the model H2. So, the one thing we have to remember, we have given the importance of the misclassified point alpha 2. So, we have to find the class. We have to find the weight of this classifier also. Means this classifier is H1, and this classifier doing the correct job for these points without these 3 points, without these 3 misclassified points. The classifier doing the correct job. So according to basis of this value, according to basis of this accuracy value, we have given the weight of this model H1. So the value of this accuracy is, the value of the weight of these models is alpha 1. So it is the simple, the alpha 1 is the weight value. This is the simple weight value of the model H1. Okay. Now we have been building the data set D2 using the help of this model H1. Now using this data 2, we have to build this is the first, this is the H1, this is the simple H1 that we have built. Now using this data set, we have built the another models with the help of these data sets. We have built these models H2. So using these models, and we have given the importance of these points. So according to these data sets, if we build, we have seen that our model will be look like this. And if you see these models, the left side of these models are positive and the right side is negative. So in these models, we have seen that our models give the incorrect output for this point, incorrect output for this point, this point, this point, this point. These 3 are the misclassified point here. These 3 points. These 3 points are the misclassified point. Misclassified points. These 3 points are the misclassified points. And since these are the misclassified point, now we will give the more importance for this misclassified point to generate the next data set D3. Okay, the same job we have to do, that we have doing in first round. Also in second round we have to do the same job. Okay, since H2, the model H2 that has been built by using the data set D2. So here the job are doing correctly for these points without rest of these 3 negative points. So because the 3 negative points, they have not doing the correct job for these 3 points, we have given the more importance for this misclassified point and build the data set D3. And according to our accuracy value, we have find our accuracy, we have find the weight of this model H2. So here what is the actual weight? So here our weight value for this model H2 is alpha 2. So in this stage, in the first stage, we have find the weight alpha 1 for H1x. Here in the second stage, we have find the weight alpha 2 for the model H2x. Okay, in the second stage. and we have given the importance of the misclassified point to the build the data set D3. Okay, now using this data set, now using this is the sample, this is our H1, this is our H2, and now using these D3 data sets we have to build another. Okay, now using this simple, just see this thing here, our weighted point is these 3 points are more weighted point, and according to this thing, according to this data set, if we build our model, then our models also look like this. At first stage we will give the importance of this 3 misclassified point. Now in second stage we will give the importance for these 3 negative misclassified point. So at the final at the third stage, at the third round, we will give the we will build the, using these D3 datasets, we will build this model and this model. Just see these models. That is the H3 models. That is the H3 models. And here we have see only here we have see that here is one misclassified point. One is misclassified point. Here is also misclassified point, and here is also misclassified, and rest of the points are okay. Okay, so here also we have 3 misclassified, but the thing is that also in previously we have built 2 models. So these misclassified points are handled by H2, and these 2 misclassified points already in previous stage that are handled by H1. So we have not confused of these 3 misclassified points, because our previous build model, that is H1 and H2, already handled these confusions. Okay, so I think after this stage all the points are correctly classified. So what are actually and what are actually we have doing this? First we have taken our initial data and we initialize a decision tree with depth 1. So in depth 1, this is been decision stamped. This the plane that divides this whole data sets, it may be vertical or horizontal. And using these data sets, in first round we have to build the decision surface of this scene. So first we have to build the decision surface, this one H1, and we have seen that these decision surface are correctly doing the job without rest of these 3 positive points. And since it is not correctly classified these 3 positive points, we will give the more importance for these 3 positive points. And according to this we have built the data sets D2. Okay, first we have given the more importance. Because of that we will sign that larger, we will sign this thing as larger sign. And using this D2, now we will build our next model H2. And already we have to mind this model H1 is already built, and we will decide some weighted according to our accuracy value. Now by using simple D2 we will build our model H2, and in H2 we will see that our misclassified point is these 3 negative points, and again we will give the more importance for these 3 negative points, and also previously we will give the more importance for the these 3 positive points, and now here we will importance for these 3 negative points. And already we have built now H1 and H2 models. Now using these D3 models we will build the next model H3. And H3 we will see that here 3 misclassified point we have, this negative point and this positive, but these 3 misclassified point already handled by the previous model H1 and H2. These 2 positive points are taken care by the H1 models, and these negative points are taken care by these H2 models. So we have all the points are correctly classified. So now according to the accuracy of the H3 and according to the accuracy of the H3, we have decided our the alpha 3 weighted value of these models, alpha 3 H3. Okay, alpha 3 H3. So all the things are combined. We have all, at the end of the day we have to combine and combine all the things. So just see this thing, all the models are interrelated step by step. First we have to build the H1, and with the help of this H1 we have to build the H2, and with the help of this H2 we have to build the H3, and all the models are intercorrelated, and the final classifier will be this one. This one means what? This one means our simple alpha 1, this means alpha 2, this means alpha 3, and this one is simple H1, H2, and this thing H3. This thing H3. By combine this thing, additively combine these things to build our final model. Additively combine these things. So our final model, that is F3 of X will be what? Alpha 1 H1 plus alpha 2 H2 plus alpha 3 H3. By simple doing, we have to doing these jobs to build the final model. And now we will see that all the classifier, all the points are correctly classified. Just see this thing. First we have give, first in H1 we have give the more importance. First in H1 we have give the more importance what? These 3 points. In H1 we have give the more importance. Just I am using the different color to understand it. In first step we have give the more importance for these 3 points. Now in second stage we will give the more importance for these 3 points, rest 3 points. I think this one. In second stage we have give, and in third stage we will give the more importance this the rest 3 class the points. It's this one, and this one. This one and this one. Okay, in stage 3. This is our misclassified in stage 3. Just say this thing. Okay, so after end of the day our all the points are correctly classified. Just see this thing. So this is this first thing is actual our first is our actual H1, this is H2, this is H3, and the left of the H1 is positive area, and in this side is negative area. Also this side is positive area, this side is negative area. So the combinations of these things is positive area, because the thing is handled by these things are positive will be negative, these things were handled by this alpha 1, because S models we have some weighted. So okay, so weighted alpha 1 means just see this thing. Just if you just draw this thing, I think this thing will be clearly. First what we have to do, first we have build the model H1. These things is positive, these things are positive, and these things are negative for H1. For H1, and also how much importance we have, and first stage we have decided the importance is alpha 1 here, for this importance alpha 2 here, alpha 1 here. Now in the next stage we have built the model H2. If we have built the model H2, thus I am taking the different color to better understand all of us. H2, this line H2. In H2 this side, just see the same color. This side is positive point, this side is positive points, and its weight is alpha 2, and this side is negative point and it's alpha 2. So we have to decide it in H2, we have to decide it the middle regions. Actually this is positive, this is negative, no matter, no, don't worry, don't be confused, but the confusion area is this one. H1 says that this area is negative, but H2 says this area, this middle area is no, positive. So how to decide? How we decided these things by using the combinations of alpha 1 and alpha 2, and the combinations result will decide what will be the actual output of these regions after the stage 2. Now at the end of the stage 2 we have built using the data set D3, build the data set D3, and we have built the another models. The another models, just I am taking the another models, this one H3, and H3, in H3 these regions, in H3 these regions are positive, and these regions are, and I'm taking the different color. Okay, I think this color already updated. This color, okay, this color alpha 3, alpha 3, and this alpha 3. Okay, so this color is, this region is positive, so already these things are positive, already these things are positive for H1, for H2, and also for H3. Don't be confused of this area. Also these things, also this area, H3 says that this area are negative, and H2 say that, and H3 say, H1 and H2 they know it will be positive. So by simple combinations of these three alphas, three models will decided, finally decided what will be the actual value of these regions, positive or negative, by simple using the combinations weight value. Okay, that will play the major roles, and what will be the intercept results of the edge area. Okay, this is the main concept. Just I suggest you please take an example and play with these examples. Okay, play with these AdaBoost models, and I think that theoretically, if you just doing the calculation manually, then the thing are easily understandable. So just take any binary classifier, example, and apply this AdaBoost technique on that. First is simple, using any decision tree, just that regular decision tree, that just simply apply on these models, and simple by using this technique and this decision tree, just find the misclassified point and give more importance of this point. Okay, and find this accuracy, and according to this accuracy decide a coefficient value of these models. Okay, and after finding the accuracy, next using this model, using these data sets, build another hyperplane. So by simple taking care of the H1 and H2, by combine this, and by combine this we have built the another data set D3. Okay, the data set D3 are built by using simple combinations of H1 and H2 that we have seen, means H1, this is for H1, this is for H2, that is combinations. And now D3, using this D3 we have built the H3, and each H3 is also taken care by this misclassified point, and this, since these are misclassified, we will give the more importance at the end of the result. Okay, so at the end of the results, all the points are correctly classified by simple doing this. Just I am giving this example to understand how actually internally these things actually work. So our decisions, the intercept area taken the decisions by using simple the combinations of the edge weighted value. So this is the simple main primary concept. I think first take any easy example, any easy classifier data, binary classifier data, and apply this concept on. Then I think then it will be very clear, and it is the most interesting theorem, and most interesting boosting theorem. And these theorems are dramatically and a huge work, mainly in Facebook, anywhere, in any face detection, problem. These AdaBoost techniques are dramatically used, and it is the main advantage of this AdaBoost. It's work dramatically in image data, mainly in image data. Okay, I think from these explanations, from this example, I think the main idea of you are clear.